Hello everyone and welcome back to our channel. So in the previous video we talked about spatial domain filtering, and this video we're going to talk about frequency domain filtering. So first of all, let's understand what is frequency domain. So in the previous one we were using pixels and we were manipulating each and every pixel to better our image. But now we will be talking about the frequency. So our image will be light somewhere, dark somewhere, and it has different frequency at different places. So if we plot it in a graph, we will have a frequency like this or even like this. So frequency of a component over a range of frequency. This is the frequency of a component. So this is our image like this, suppose. So this one will have higher frequency than this one, obviously. So it represents the frequency of a component over a range of frequency. So that is our frequency domain. There are three types of filters that we can apply, and those are low pass filter, high pass filter, and band pass filter. I have very concisely explained over here. If you need a very good explanation on this, then please check out the NPTEL lectures. But this is quite good enough for last moment revision types of stuff. So we have low pass filter. This removes the high frequency component, and it smooths. As we saw in the last video also, low pass filters are basically used for smoothing and high pass are for sharpening. So it removes the high frequency components. So it can mathematically be represented like this: G of UV is equal to H of UV dot F of UV. H of UV is the Fourier transform of the filtering mask. So we have a filtering mask, and the Fourier transform of that will be represented by this, and this is the Fourier transform of the original image. So basically we will be given an image. We first have to find the Fourier transform and then the Fourier transform of the filtering mask, and then those two will be combined or multiplied to get our final low pass filtered image. So this is quite of a big task to do. So but this is how it is performed. In high pass filter we do sharpening, and it is quite similar to this representation, and over here basically H of UV is calculated by 1 minus H dash of U comma V, where H dash of U comma V is the Fourier transfer of the filtering mask. So we subtract it from 1 and then we get the Fourier transform of the filtering mask that we use for high pass filters, and the other remains the same. After that we have band pass filter, and in band pass filter what we do is it keeps moderate range frequency. So it will remove all the high range frequency, all the low range frequency, and it will keep the moderate one. So if we have something like this, then it will remove the upper and lower one, and it will keep all the moderate ones. So that is band pass filter. I hope this was a clear enough explanation. If you did like this video, give us a thumbs up. Also subscribe to our channel, and I will see you again in the next video. Till then, take care and bye bye.